Welcome to the Backyard Professor Math videos. We are going to continue preparing ourselves, familiarizing ourselves, I should say, with linear equations and equations like linear equations so that this becomes a snap. From here on out, man, in algebra, trig, calculus, we're going to be doing linear equations and we'll learn how to graph them, and we'll be learning that too. So the more we become friends with them now, it just makes our road ahead of us a lot easier. So, negative y over 9 equals 14. We've seen equations like this. Someone has divided our negative y by 9, so we're going to multiply by 9, and that's going to cancel the 9's. So this is 14 times 9. 126 equals 126. Good grief, I can't write. However, we have a negative y, right? Why? Who knows? The negative's there though. So we have negative y equals 126. This is equivalent to negative 1y. You remember, every time we see a negative, there is an implied negative 1. How do you get rid of the negative 1? You divide by negative 1. Divide by negative 1. If you divide here, you divide there, and therefore y equals negative 126. That's how that works. Cool, isn't it? 3x equals 51. Someone multiplied by 3. We're going to isolate the x by dividing by 3. Dividing by 3, x equals 51 thirds. You can leave it just like that, and it's perfectly fine. If they want you to do a mixed number, 3 goes into 51 how many times? Once. Into 5, with the 21 left over, 17. 3. So the whole number answer is 17. The fraction is 51 thirds for that particular answer. What if we're told 84 equals 8x? Now here it's gone backwards almost, huh? We're given the answer and then it equals the number times the variable. What do we do in case they switch it around? Here's the beauty of math, you guys. I'm not kidding. It's the same operation. You're just working on the other side of the equation with the variable. That's perfectly fine. How do you isolate x? You divide it by 8. The 8's cancel. X is alone. If you divide by 8 this side, you divide by 8 that side. So x is 110 and a half. 10 and 4/8, and 4/8 will reduce to 1/2. So there's your answer. It doesn't matter what side of the equation the variable's on, the same operations apply. It doesn't matter if you have a negative and a positive number. It doesn't matter if you have a huge number and a small number. It doesn't matter if you have a fraction. It doesn't matter if you have a mixed number. It's irrelevant. The operations are the same. 5x equals 50. Divide by 5, x equals 10. By now, these are absolutely a piece of cake. 8x, well, let's say 88 equals 8x. Here we have x on the other side of the equation, but the operation is the same thing. We divide by 8 to isolate x here. We divide by 8 here, so this says 11 equals x, or x equals 11. Either way, it's perfectly fine. Now we have 8 minus x equals negative 1. Someone has subtracted our x. Remember, as long as you keep the signs, you can switch places. We don't write the positive sign with positive numbers, but we do write the negative sign with negative numbers. So if you wanted to switch this, if it helps you clarify, this is equivalent to negative x plus 8 equals negative 1. Now you can see that you need to subtract 8, and -1 minus 8 is the same as -1 plus -8, which is -9, and then we divide. We have a negative x here, which is a -1x. It's an implied -1, so we divide by -1 here, we divide by -1 here. Now this is fun and interesting because -1 into -9 ends up being +9, not negative. That's why you want to be real familiar with your positives and negatives for that reason. Isn't that fun? That's cool how that works. Oh, mathematics is good. Mathematics helps you think clearly. It gives you perfectly logical thinking. It helps you think hard. It develops brain cells. And it makes us intelligent, indubitably. If you don't know the meaning of that word, look it up, man. Okay, let's do another one. 6x equals -48. Someone multiplied our x by 6. We got to divide it. That'll cancel. What you do to that side, you do to this side. 6 goes into -48, -8 times, because there's only one negative in the division. And 1 is an odd number. If there were 2 negatives, it would be a negative divided by a negative, which would make that positive. But with 1 negative, you end up with a negative. Okay? Remember that. -21x equals -63. We know it's been multiplied, so we know we have to divide by the exact same number, -21. -21. This isolates x. These will cancel. This isolates x. And this is a -21 into -63, which is +3. Negative divided by a negative is a positive. And I know I'm emphasizing this, I'm overemphasizing this, because we want to be familiar with it. We want to be so comfortable with it that it almost becomes like secondhand stuff. We don't want to struggle here with this. So we have 3/5 g, and I'm just using different variables all over the place because that's exactly what math does, equals 9/15. Now you see a couple of difficult fractions and you're saying, oh dude, no, don't do that. We know that to get rid of a multiplied fraction with a numerator, what we get to do is we multiply it by its reciprocal. What does that mean? We're going to take this fraction and turn it upside down and multiply it. So what's opposite of 3/5? 5/3 times 3/5. Remember when I told you you were going to want to learn how to turn fractions into a number one? We do this a lot in linear equations. This is a very powerful technique. Now you're going to get to see it in action. And what does this do? We're multiplying by the reciprocal, flipping it upside down. So then you just multiply the numerator across, denominator across. You don't have to worry about common denominators with multiplication and division, right? So 5 times 3 is 15. 3 times 5 is 15. And any number over itself simply equals 1. What this does is it makes this into 1g. So we just drop the 1. Any number, any variable that is multiplied by 1 is simply that variable. Try it. What's 4 times 1? 4. What's 88 times 1? 88. What's x times 1? X. What's g times 1? G. So now we have g. However, 9/15, we did multiply 3/5 by the reciprocal on this side, So we do the same thing to it on this side, multiply by 5/3. And in multiplication, you just multiply across. But look at these numbers. We have factors of multiples here. 3 goes into 9 3 times. 3 goes in, we can cancel 3 down to 1 and cancel 9 to 3. 5 goes into 15 3 times. We can cancel 5 to 1 and 15 to 3. And now when we multiply across, we see that 3 times 1 is 3, and 3 times 1 is 3. Any number divided by itself is simply 1. And there's your answer. 3/5 G equals 9/15. G is 1. And why does that work? Let's look at this. 3/5 times 1 equals 9/15. But wait a minute, those aren't the same numbers. Yes, they are. Watch what happens. Remember what the number 1 can be written as? Any number over itself. How does 3 get to 9? By multiplying it by 3. How does 5 get to 15? By multiplying it by 3. But 3/3 is the same thing as 1. So this is simply a true equation. 3/5 is the same thing as 9/15. But you need to see how to isolate the variable so that you can verify it. We'll do this a lot with linear equations. That is cool. I got news for you. That's cool. Okay. Negative 3/2 t, probably for time, equals negative 27/4. With linear equations, we have a lot of times fractions multiplied to the variable. And sometimes it equals fractions, sometimes it equals whole numbers. You'll see this is actually just a whole number, won't you? Almost. It's a mixed number. How do we get rid of negative 3/2 and isolate t? You flip it over and multiply by its opposite. But you can't forget the sign. You gotta have the negative, dude. Or babe, whichever sex you are. So we multiply by negative 2/3 times negative 3/2. And that simply goes to 1t. And we can ignore the 1, so that's how we isolate the t. And t equals negative 27/4. But we multiplied by negative 2/3 here, so we have to multiply by negative 2/3 there. You don't want to change the relationship, the ratio, the proportion. You don't want to change the meaning of the fraction. Keep it the same. So we multiply on both sides by the same number. We know that by now. I'm about ready to quit explaining that so hard. 2 and 4 can cancel. 2 can go into 2 once and into 4 twice. And you only cancel through diagonal. 3 can go into 3 once. That should be negative, sorry. That's a negative. And 3 goes into negative 27, negative 9. So we have negative 9 times negative 1 is 9. 2 times 1 is 2's. And there's your answer. 9/2. Very fun stuff, isn't it? Okay, let's keep looking. You will see, you're going to thank me like crazy later for emphasizing all these kinds of problems, because you will see that linear equations are like this constantly. And if you practice now and have good familiarity with it, you are going to love linear equations. m over 3 equals 1/5. So we're told this equation is an equality equation. Some fraction that we don't know the numerator is going to equal 1/5. What do we do to find that? Simple. Break it down. Here's your variable m. What has someone done to m? They have divided by 3. Undo that by multiplying. You multiply by 3 over here, the 3's cancel. You multiply by 3 over here, 3 is the same as 3 over 1, and now you multiply straight across. 3/5. There you have it. Three-fourths x. A fraction multiplied to a variable equals 27. To isolate it, we flip the fraction over, multiply by the reciprocal. This is 3/4. We're going to flip it 4/3 times 3/4 equals x equals 27 over 1 times 4/3. 3 and 27 can cancel. 3 will go into 3 once. 3 will go into 27 9 times. 9 times 4 is 36. 1 times 1 is 1. We know any number over 1 is simply a whole number, so 1 divides into 36 36 times, and there's your answer. The answer to that one is 36. By flipping the reciprocal and turning fractions into 1, this is a very popular, this is very common operation in linear equations. We want to get used to this, truly. If we have 1/5 z equals 19. Now, it doesn't matter the size of the fraction. It doesn't matter whether the number here is negative or positive. It doesn't matter if you have a z, a f, a d, or an a as a variable here. The rule with fractions multiplied to variables is you reverse the fraction, multiply by the reciprocal on both sides, and your answer comes out automatically. It's almost like you don't even have to think. Watch. We're going to multiply this by 5 over 1, which is just 5. The reciprocal of 1/5 is simply 5, right? 5 times 1 is 5. 1 times 5 is 5. And 5 over 5 is 1z. We can eliminate the 1 because the z is by itself. This equals 19 times 5, which is 90. And there's your answer, 90. It's that simple. This is what is so fascinating about multiplying by the reciprocal and what gives linear equations their ease. Now, linear equations can get complex, not necessarily more difficult, but more complex, and we'll build complexity to build familiarity as we get going. But we understand the operations, and therefore don't worry about the size of the numbers. Don't worry about the size of the fractions. Don't worry about whether they're negative or positive. Do the operations, isolate the variable, and by isolating the variable, it absolutely automatically tumbles the answer out. Every time. Sometimes the answer will be in fractions, sometimes they'll be whole numbers. It's okay. 2/3 k equals 6. To isolate k from a fraction, we multiply its reciprocal. 3 2's times 2/3. 3 times 2 is 6. 2 times 3 is 6. 6 over 6 is 1k. We can ignore the 1. It's just k. Equals 6 times 3 over 2. If it helps you see this simpler, put 6 in a fraction form. Then multiply straight across. But before you multiply, look, you can cancel right now. 2 will go into 2 and 6. 2 will go into 2 once. 2 will go into 6 3 times. So this is 3 times 3 is 9. 1 times 1 is 1. And any number over 1 is simply that number itself. 9 over 1 is simply 9. It falls right out of the equation when you multiply by the reciprocal and make fractions into 1. We don't want this to be complex and hard. We want to learn the process of how to solve the equations so that we can do this with any kind of equation that's thrown at us, right? We're not looking for speed, we're looking for accuracy. And baby, this is it. We love accuracy, yes we do. We love accuracy, how about you? Now you know why I kept my day job, because I can't sing or spit, right? Okay, let's check this out. Doesn't matter what fraction. 4/7 m equals 13. It doesn't matter what number, it doesn't matter what variable, it doesn't matter what fraction. This is easy. Multiply by the reciprocal of a fraction to isolate it from the variable. 7/4, the reciprocal is just simply turning the fraction upside down, times 4/7. 7 times 4 is 28. 4 times 7 is 28. 28 over 28 is simply 1m, equals 13, which is 13 over 1, times, what was the reciprocal of 4/7? 7/4. Can anything cancel down? No, it can't. So we have to multiply straight across. 7 times 21, 70, 91/4. And there's your answer. It's that simple. This is so fun when it's simple. It doesn't even matter, you guys. We have proper fractions here. What if we have an improper fraction? That's okay. Look. Let's say we have 8/11 z equals 8. Uh-oh, we've got an improper fraction. Does that goof our operation up? Not a bit. You multiply by the reciprocal of that fraction to isolate your variable. What's the reciprocal of 8/11? It's 11/8. So we take 11/8, multiply it by 8/11. What does that give you? 88 over 8 times 11, 88. What is 88 over 88? Simply 1. 1z equals 8 times, what's the reciprocal of 8/11? 11/8. So we multiply this by 11/8. 8 is simply 8 over 1, if that helps you visualize it easier. The 8s can cancel each other, so you have 11 over 1, which equals 11. That is almost easy as adding 2 and 2 now, isn't it? Isn't that cool? Do I have time for one more? I have time for one more. Oh, I've got a few more I wanted to work through. Okay, that's okay. 11/3 x equals 9. Again, multiply by the reciprocal. That's going to be 33 over 33. That isolates our x, so x is alone. But we multiplied by 3/11 here, so we have to multiply by 3/11 here. I think we multiplied by 3/11, didn't we? Yes, we did. And this is 9 over 1. So this is 27. 9 times 3 is 27. 1 times 11 is 11. Your answer is 27/11. Man, it's that simple. Now, these are really excellent introduction information to familiarize ourselves with linear equations. Now we're ready to jump on linear equations. And they take all varieties, all kinds. We'll begin with easy ones. Then we'll gradually add the complexity, which just means we add another couple operations. It does not make them more difficult. It makes them more complex, which means we need to take just a couple extra seconds and work through the extra operations, right? So anyway, That's it for today. Thanks for watching my videos. Remember, happy calculating. Don't forget, have a great life. And absolutely don't forget, I'll see you in the next video.